When I committed to the title of this talk, I suddenly realised, of course, the Victorians know nothing about AI, but fortunately they do know a lot about transformative technology. And we seem to have, I think, forgotten a lot of the lessons from that age. So I'm here to talk to you about that. That's Victorian me. It has a lot more hair than actually I've got right now. So I had a bit of fun on the title slide there. So my working kind of thesis really for this talk is that actually we only see the real impact of transformative technologies like AI when we design the systems around the technology. So we've got lots of examples really through the Victorian age and the Industrial Revolution of where the real change happened at the sort of second order effect level rather than the first order effect level. So my sort of pitch to you today really is that AI is not an efficiency story. Right now there is so much focus on efficiency, optimization. It's really about, it's a remodeling story. It's about redesign and reinvention. Unfortunately, we have a really good example of this. So this is Thomas Edison, of course. So Thomas Edison built the first electric power station, and this was in Lower Manhattan in New York. And for the first time, factories that were positioned around the power station could have electricity as their source of power. Electricity, of course, is a general purpose technology. It spawns lots of other innovations, a bit like AI, of course, as well. But it took, you'd think factory owners, when they could electrify manufacturing, would be all over that. They would be really keen to adopt the new technology and electricity. But in fact, it took factory owners 30 years to want to electrify manufacturing. Now, before electricity, factories had actually been powered by steam. So you had a big steam engine that sat at the center of the factory, and the whole factory was designed around that central power source. And you had all of these belts and shafts that came off the big steam engine to power the individual workstations. So, of course, when they introduced electricity for the first time, they did the obvious thing, which is to take out the big steam engine from the center of the factory and to simply replace it with a big electric motor. But they hadn't really changed very much at all. The layout of the factory was pretty much the same. They still had all of the belts and shafts and so on. And so the factory owners didn't really see any productivity benefit at all from the introduction of electricity. They weren't interested in it. It took them 30 years to learn the lesson that what you could actually do with electricity was, instead of having one big electric motor at the center of the factory, you could actually have hundreds of little electric motors, one at every individual workstation. And that meant, of course, that you could do this, mass production. It meant you could redesign the entire way in which factories worked. So the layout changed, the way that production lines worked, of course, changed. It changed how people worked as well, because you could specialize and get good at one thing on the production line. Absolutely everything changed at a really fundamental level. But the lesson behind this, of course, is that it took them 30 years to get there. And the reason is because what the factory owners were doing is what we often do with new technology, which is that we look at the new through the lens of the old. We look at the new through the lens of the old. And sometimes the opportunity is much greater than that, particularly with general purpose technologies. It's a bit like this, which is a metaphor I quite often use when we're thinking about change. So navigating change is likely to involve, particularly technological-driven change, is likely to involve optimization and efficiency, but also quite transformative change as well, particularly when it's a general-purpose technology like AI. So the grasshopper is a good example of optimization. Big grasshopper looks like a small grasshopper. It just sheds its skin as it grows larger. So really the opportunity here is, of course, to get bigger, better, faster, more efficient at what you are doing. Right now, the focus is very much on that through automation, of course. But the benefits of that, I think, will top out pretty quickly. When everybody is using similar tools to do roughly the same sorts of things, where's your competitive advantage? So actually, I would say that the real competitive advantage will come from transformation, from designing the system around the technology. And this is a bit like the caterpillar turning into the beautiful butterfly, of course. You have this sort of messy middle stage in the middle here when you don't quite know how things are going to work out and how they're going to shape up, but actually that's the way in which you're able to achieve the redesign and reinvention. So The Victorians can actually tell us quite a lot about this because, of course, they had lots of technological-driven change. So, for example, the elevator, of course, had lots of second-order effects, not just first-order effects. So, when Elisha Otis did his first demonstration of his safety elevator in 1854, of course, the most valuable floors in a building were actually the ground floor and the first floor. In fact, in Paris, they called the first floor the noble floor because it was the floor of kind of highest status. More stairs meant more effort, meant lower status. But of course, the elevator completely subverted that social hierarchy, and so penthouses suddenly became the premium. But also, the elevator did something else, which is to enable the skyscraper. And of course, that changed the urban environment forever. Not just in terms of land economics. So the land economics, the value of a piece of land wasn't only determined by the sort of footprint of the land, but also by the number of floors that you could stack onto that space. But also things like fire codes and building regulations and zoning laws and things like that. Absolutely everything fundamentally changed because the assumption changed, and now you could actually go up, not just outwards, of course. So the elevator is a really good example of actually how the real impactful change happens not when we're focusing on first-order effects, which is things like safety and application and speed, but then on second-order effects, which is about infrastructure and social norms and behaviors and culture. So the telephone, sometimes this can take quite a long time, I think, to come to fruition. And often what happens here is that we make assumptions at the beginning which turn out not to be true. So the telephone is quite a good example, really, of how it can take quite a long time for these real kind of transformative effects to come through. When Bell and Watson invented the telephone, it was actually marketed originally as a one-way device, a broadcast medium. The idea was that people would have these devices in their parlors, and then concerts and lectures would be sort of piped down the telephone line, and you could all sort of listen at the other end of the line. Not a great user experience, I would suggest. But actually, it took about 20 years for exchanges and so on, switchboards, to actually make person-to-person communication viable. And then another 10 years after that for the telephone to change environments and to create social impact. So often the kind of first view of how we see the technology is not actually where it ends up. So my favorite example actually of kind of making assumptions about what early assumptions really about new technology is the telegraph. Because the telegraph came about in sort of the mid-19th century. And the Victorians believed that actually the telegraph would change everything, and it would we'd have no more wars, because the idea here is that when countries could communicate to each other in near real time, we'd have no misunderstanding, and it would be like peace and brotherhood amongst men. And of course, as we know today, to our cost, that is very much not the case. But the telegraph did bring significant big change. It enabled things like colonial expansion. It enabled real-time or more real-time kind of financial markets, and so financial markets expanded globally. It tightened things like military command and control, and it enabled the kind of real-time sort of news cycle that we're much more familiar with today. But so the key lesson really from these examples, of course, is that those early assumptions about what the future is going to look like often turn out to be completely misaligned. And just that, they are assumptions, and it turns out to be something completely different. But sometimes, actually, what can happen here, this doesn't really stop at just that sort of first systemic change. It kind of cascades outwards a bit like the elevator. And sometimes it can change the environment in ways that actually means that it's impossible to opt out. So quite a good example of this is the railways. So before the railways came along, towns and cities in the UK would have their own local time based on the position of the sun. So Bristol was 11 minutes behind London. Now, that was fine when the fastest thing to go between Bristol and London was a horse, but it kind of made railway timetables unworkable. And so in 1847, the Railway Clearing House forced all kind of railway managers and owners to use Greenwich Mean Time. And it spread out from there around the country. And so what that meant effectively was that everybody defaulted then to Greenwich Mean Time. And it meant increasingly for businesses that you couldn't opt out of that change. It became functionally impossible to actually still work to local time. So the lesson of this, of course, is that transformative technology doesn't only change the environment quite systemically, but sometimes it changes it to the level that we can't actually opt out of it, and everyone has to follow those particular norms. Now, this becomes particularly true, I would say, when the switching costs get higher over time, the switching costs of those kind of social norms. The typewriter is actually a really good example of this, because the first versions of the typewriter actually had a keyboard that was laid out alphabetically. So 2 rows of letters like A, B, C, D, E, F, and so on. But as typists got faster, the mechanical keys started to stick and to jam. And so in 1873, Christopher Sholes redesigned the keyboard, and he decided to sort of separate up some of the most commonly used letters. And he was designing it to actually slow people down, to slow the sort of speed of typing so that the keys would jam less. And he designed what became the QWERTY keyboard, of course. Now, we have had since that invention a lot of other versions of the keyboard, a lot more ergonomically friendly versions of the keyboard, including things like the Dvorak keyboard in the 1930s. But by then, of course, millions of people have been trained to type on the QWERTY keyboard, and so the switching costs were really high. So as word processors and then computers and then mobile phones all adopted the QWERTY keyboard, it's actually pretty unthinkable today that anyone would actually use anything else apart from the QWERTY keyboard. So the lesson of this, of course, is that the kind of norms that we establish around things like AI now, we have to be cognizant of what those norms are, because perhaps switching costs are going to rise to the point where actually we can't opt out anymore, and that actually this becomes the default for everyone. So there's another, perhaps more uncomfortable lesson here, which is illustrated by the chart on the right-hand side here. So in the early decades of the Industrial Revolution, there were significant productivity gains, new factories, new machines, and so on. But the wages actually were stagnant. They didn't rise at all. Workers were working longer hours, they had poorer conditions, and tougher jobs. And so effectively, all the benefits of the early years of the Industrial Revolution, the new technologies and machinery, were flowing to the owners of capital. This was called by the historian Robert Allen the Engels pause. For 50 years, the benefits flowed to the owners of capital rather than the actual workers who were doing the work. Between 1790 and 1840. He named it after Friedrich Engels, of course, because Engels wrote the famous book, of course, about the conditions of the working class in England. But of course, what we need to pay attention here to is not just how technology is changing the environment, but who is benefiting from that change. So I'm going to finish with a couple of last examples here, perhaps maybe a couple more hopeful examples. So this is Andrew Carnegie, who made a fortune in the 19th centuries from his steel empire, became one of the richest men in the world. And he then became a philanthropist, and for his legacy, he wanted to build a network of libraries. And in fact, in 3 years, 1,700 libraries were built across towns and cities in the United States, and even some in Great Britain as well. And nothing like that had happened before, of course. Nothing like that has happened since. But there was a recent study that was done on the impact of those libraries on innovation. And they measured the rate of patent applications on towns and cities that had a Carnegie Library built versus towns and cities that had applied to have one built but were refused. And the study showed that in the 20 years after the Carnegie Library was built in that town or the city, the rate of innovation was 7 to 11% higher than the towns and cities that hadn't had a Carnegie Library built. So in other words, access to knowledge, just from ordinary people having access to knowledge, is a real boost to innovation. So of course, I think that AI gives everyone access, even more than search, to knowledge. And so the potential here is that actually we can have a huge boost to our innovative capacity just by connecting everyone to better access to knowledge. So my last example is quite a hopeful one as well, which is photography. So in the kind of middle of the 19th century, the first daguerreotype was invented, the first sort of camera. Prior to that date, painting, painters and artists, had really been characterized by realism. So the more realistic your painting was, the more that the more value it had, and the more people appreciated it. But of course, what cameras were very good at was capturing that realism much better than a painter could. So as soon as you could take a picture, people were saying things like, why would we need painting anymore? In fact, the artist Paul de la Roche said, from today, painting is dead. But of course, it didn't kill painting. The new technology actually spurred new forms of art. And so after the camera was invented, we had things like post-impressionism and abstract art, and even different forms of. In fact, every major form of or new type of painting came after that date, spurred by the invention of the camera. So the thought I would leave you with today, just to come back to the point I began with, really, is that AI is not an efficiency story; it's a remodeling story. And what that means is that we need to take a deliberate approach to how we are designing for it. I don't think this is a story really about AI versus human, or AI being completely different to humans. It's about how you combine the strengths of each one to be greater than the sum of the parts. And human and AI learn in fundamentally different ways. They are good at very different things. But it does mean that actually the choices that we make now are going to be really important for the future. And we need to take a deliberate decision about how we design for the balance between human and AI. So the Victorians can actually tell us an awful lot about our future, our AI-enabled future. Thank you.
Thank you, Neil. Are there any questions from the audience after the coffee break? You've all been recharged by coffee, but I can't see any hands going up. I love the fact that Bristol's was 11 minutes behind.
I know, right?
London.
Yeah.
I can't work out if that falls in everything has changed or nothing has changed. Or is that a bit rude to people? Sorry, apologies. That's just me being annoying. We've got a question. Here we go.
Hiya. On that last slide, right over on the right-hand side, you had that question of when there's not enough context, then the humans should create and AI should evaluate. If there's not enough context, can AI even be adjudicating, or is that actually when you just have to accept it's not the arbiter of the decision?
Yeah, well, I think you sort of hit the nail on the head. I would say up that end, this is where the human needs to be the driver. So the context comes from the human judgment. The AI might be used in the support of that process, but the human needs to say the driver of that process. Down that end, arguably, you've got much more kind of automation, which is where you can actually design the process and it's a repeatable process, and so maybe the AI takes much more control of that. That end, I would say, is much more about cognitive sovereignty. Yeah, there's quite a lot of talk about cognitive outsourcing at the moment, but cognitive sovereignty to me means that the human actually is staying the driver and is saying, that's the thing that's interesting, this is the thing that we should do next, that's what I would like to do with that sort of insight or that piece of data, for example. And that's very much at that end of the chart.
And do we think we can trust AI to know when to step back?
So up that end of the chart, I would say that is for the human to set that. So it's for the human judgment to say when AI can actually support that process, I would say. AI has no accountability, so I would say probably not. So it's not very good at telling you when there are gaps or when there's things you don't actually, when it doesn't know the answer to something, of course, unless you prompt for that. So I would say that's a good reason why for anything creative, for complex challenges like that, for strategy work, the human needs to stay the driver.
Oh, we've got one more over there. Can you just wait till we've got the microphone with you, just so people can hear the question?
Hi. You spoke about factory owners. When the electricity came in, they were using it through the lens of the old.
Yeah.
What do you think are the traps we might fall into of using AI through the lens of the old?
Good question. So fundamentally, I would say that actually, if you're just looking at it from the point of view of here's our process, the way in which we complete this task or this sort of outcome or output, and then you're looking to just make that faster, bigger, better, perhaps more efficient, without even really thinking about is there a completely different way in which we can achieve that outcome. What you're really doing there is you're doing what you did before, but you're doing it faster and more efficiently by using AI. And I think that's a natural place to start, right? So no reason at all. There's significant value in optimization and automation. But I guess my point would be that we've always got to be open-minded about the possibility of redesigning and reinventing, and that's a different mindset altogether, I would say.